Okay, so now we're going to talk about how to do equations involving solutions using dimensional analysis. And again, the basic idea here is we start out with our volume, we change it to moles using concentration, we use the ratio in the balanced chemical equation. That'll give us moles, and so we need to divide by volume to get concentration. So let me show you what I mean. So we're starting out with 0.4 decimeters cubed of sodium hydroxide. We don't want volume, we want moles, and so we're going to use our concentration to get rid of that decimeter cubed. We know for every 1 decimeter cubed, there's 0.1 moles of sodium hydroxide. Now, according to chemical reaction that we saw above, or if you want to rewrite it out, we know that it's a 1-to-1 molar ratio between HCl and NaOH. And now, because we're trying to find the concentration of hydrochloric acid, and doing this would just find the moles of hydrochloric acid, we actually need to divide this number of moles by 0.56 decimeters cubed so we get the right units. So if you take a look here, we have decimeters cubed of NaOH, moles of NaOH, moles of HCl per decimeter cubed, which is our units for concentration. Doing this in my calculator, I would type 0.4 times 0.1 times 1 times 1 divided by 1 divided by 1 divided by 0.56. And when I do that on my calculator, I get 0.07142 blah 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 moles decimeter -3 of HCl. So these are a little bit more complicated in dimensional analysis. The main thing to think about here is that you can actually think of your concentration as your molar mass, because we're going from volume to moles using our concentration. We still use our molar ratio, and then at the end we get moles, but we don't want just moles, we want moles per decimeters cubed, so we need to divide it by the volume of what we're looking for.